Hello, my little mathematicians. Today we're going to practice setting up word problems. Okay. So, first off, I want you to try and figure out what operation you would do from the word problem. And if you know, like it's adding, it doesn't really matter which numbers you add in what order. But if you're subtracting, it does matter. And if you're dividing, it also matters. So go ahead and try and see if you can set any of these up, and then we'll go through them together. So feel free to pause the video and then try them and then unpause it and come back and join us. All right, number one says Alex was working with wooden planks and needed to measure out how much wood he had to work with. One plank was 11 and 3/4 feet long, and the other plank was 8 and a fifth feet long. What is the total length of both wooden planks? So when you're trying to solve these, also try and figure out what's your indicator that's letting you know what operation you should do. Well, this one told me what's the total length. So that's usually an indicator that you're going to try and find them added together. So I have one that's 11 and 3/4 and another that's 8 and 1/5. Okay, and I'm going to add those two amounts together in order to find the total amount. Now, when you're adding, you need to remember that you need to get what? Common denominators. So what can 4 and 5 both become? They can both become 20. And I'm going to rewrite 1/5 as a equivalent fraction. So 5 times what is 20? 4. So then 1 times 4 is also 4. 4 times what is 20? 5. So then 3 times 5 is 15. 15 twentieths is equivalent to 3/4, and 4 twentieths is equivalent to 1/5. Now you have equivalent fractions, but with the same denominator, so you can just add the numerators. 15 and 4 make 19, and add the whole numbers. 11 and 8 make 19. So that total length is 19 and 19 twentieths feet long. Now, for the rest of these, I want you to just try to figure out what the key words are that let you know what operation you should do, and then try to set them up. And then if you want to try and solve them, go ahead and solve them, and then you can go back and check the key to see how you did. Okay. For number 2, it says Ben and Cass are doing a relay race. Ben will be running the first part of the race, which is 4 and 1/8 miles long. Cass is running the second part, which is 3 and 5/6 miles long. What is the total distance that they're going to run? So one person runs the first part, which was 4 and 1/8, and then another person runs the second part, which was 3 and 5/6. They want to know that total distance covered. So you're going to do what? Yeah, add them together. Okay, and again, you can go ahead and try to solve it and then check your answers on the answer key. For right now, we're just going to focus on what operation to do. Number 3 says it took Diego 1 and 5/12 hours to finish his homework, but it took 2.5 hours for Edward to finish his homework. How much longer did it take Edward to finish his homework? Whenever you see the words how much longer, how much further than, how much more, how many more, that's an indicator that you should subtract. And it doesn't matter like what came first or second in the problem. Whatever the bigger number is, that's what goes on top. And for this one, obviously, you know the bigger whole number is the bigger number. But if they were both fractions and you couldn't tell which one's bigger or not, usually it'll give you a hint like how much longer did it take Edward to finish his homework. So Edward took a longer amount of time. So his time would be more and go on top. Okay. The next one says Faye is 5 and 2/3 feet tall. Her sister Gabriella is 4 and 3/4 feet tall. What is the difference between their heights? Well, difference usually is an indicator that you should subtract. So you're trying to find the difference between the two, which is 5 and 2/3 minus 4 and 3/4. Okay, and again, right now I'm just helping you set them up. You can go ahead and check yourself on the answer key and then see how you did. Okay, number 5 says Hetty biked 1 and 5/6 kilometers from her home toward the beach until she realized that she forgot her beach bag. So she immediately turned around and went back 2/3 kilometers back toward her house And then you want to know how far away is she from her house right now. Okay, so here's my house. Sometimes drawing a picture helps. Okay, I bike away from my house 1.56 miles. But then once I'm here, all of a sudden I realized I forgot something. So I turn around and I head back 2/3 of a kilometers back toward my house. And at this point in time, right here, I want to know how far am I from my house? So what do you think you would do? Well, this plus this is a total of 1.56, right? So if I want to know this missing piece right here, it's this plus 2/5 is equal to this. So to find that missing piece, I'm going to do the total minus this little part in order to get that missing amount. Okay? And then you go ahead and try to solve that and check your answer on the answer key. Number 6 says Abraham left a bowl of water outside to do a science experiment about evaporation. The water weighed 9 1/5 kilograms. After a week, it now weighs 8 2/3 kilograms. How much weight was lost? What do you think? Well, it started out at this much, and then now it weighs this much. You want to know the difference between them to find how much was lost. So I'm going to subtract those two amounts. If for some reason it's not that obvious, just make them easy numbers. Like say, okay, a water, it was, let's make it even easier numbers. It was 10 pounds and now it only weighs 5 pounds. Okay. How much weight was lost? And you'd be like, oh, immediately your brain's like 5 pounds was lost. Well, how did you go from 10 and 5 to that 5? Well, I took these and I subtracted them. So then do that same operation with these hard numbers. I'm going to subtract those two numbers in order to find the answer. So again, one strategy is make the numbers easier to deal with, and they don't necessarily have to be these numbers rounded. Because if like 9 and 8, you can't do easy division and things like that because we don't know at this point in time what operation I should do. You want to pick numbers that are easily to multiply, divide, add, and subtract so you can see what operation it is and then apply that operation with the harder numbers. Okay, number 7 says there were 5 mugs which could hold 1 3/8 liters of water each. How much water could all 5 mugs hold? Okay, so let's just make it be 2 liters of water, okay? So there's 5 mugs, so 1, 2, 3, 4, 5 little mugs, and each one has 2 liters of water. How much water can all 5 of these hold? Well, 1 is 2, 2 of them is 4, 3 of them is 6. What are you doing each time? You're taking how much is in each one and multiplying it by how many there are. Well, in this instance, there's 5 mugs, and each is able to hold not 2, but 1 3/8 liters of water. So if I multiply those two numbers, that'll tell me the total amount that can go in all 5 mugs. Now, when you're multiplying, just because we haven't had any of those yet, don't forget that, do you need a common denominator? No. What do you need to do? You need to change these into improper fractions. So how do you make a whole number a fraction? Put it over 1. And then for this guy, you're going to multiply the denominator and the whole number. So 8 times 1 is 8, and then add the numerator. So 8 times 1 is 8 plus 3 is 11. And then the denominator just stays the same. Once it's set up as a multiplication problem, then you can look to see if anything can cross cancel. And then you just multiply across. Well, 11 times 5 is 55. 8 times 1 is 8. You can't leave it as an improper fraction, so it's always top divided by bottom. 8 goes into 56 6 times, which is 48. And when you subtract that, you get 7. So you put your remainder over what you divided by. And those 5 mugs can hold a total of 6 7/8 liters of water. Okay, for number 8, it says Carrie's cake recipe calls for 2 2/3 cups of flour. She wants to triple it, so she can make 3 cakes. How much flour does she need? What do you think you should do? Well, when they use the word triple, that means that you want to do it 3 times that amount. So if one recipe calls for this much and you want to triple the recipe, you're going to multiply it by 3. Okay, do the same steps we did here. Put whole numbers over 1 and change any mixed numbers into impropers. All right, the last 2 on this page says Laura earns $20 an hour. Her cousin Madeline says she earns 2.5 times more. How much money does Madeline earn per hour? Let's make it easy numbers. Okay, she earns $20 per hour. If she earns, let's say, twice that amount, how much money does Madeline earn per hour? So Madeline claims, hey, I earn 2 times that amount. Well, what would you do? You'd multiply what Laura made times 2, and then that would tell you how much Madeline made, right? Well, instead of saying you make just 2 times more, she's saying she makes 2.5 times more. Okay, the last one on the page says a biker traveled 11 1/3 miles an hour. How many miles will it travel in 3 3/4 hours? Let's try and make this easier numbers. Okay, what if it said that he can go 12 miles per hour, or 12 miles in 1 hour? Okay, because that's what that many miles an hour is saying. Okay, so 12 miles in 1 hour. How many miles will you travel in, let's make it be an easy number of just 3. Okay, so in 3 hours, how far can you go? Now, a lot of you, your brain is already saying 4 miles. Are you saying 4 miles? Well, let's see if that makes sense. Okay, so in 1 hour, you can go 12 miles, but you're traveling for not just 1 hour, but for 3 hours. Does it make sense if I said 4? No, so that doesn't make sense. What else do you think it could be? Well, again, in 1 hour, you go 12 miles and you're traveling for a total of 3. So in this second hour, you're going to go another 12 miles. In that third hour, you're going to go another 12 miles. So then what's the total distance that you traveled in 3 hours? Now a lot of your brains are saying, oh, I know, 36 miles in 3 hours. And you're right. Okay, now how did you go from 12 and 3 to 36? What did you do? You multiplied those numbers, right? You took how long you could go, or how far you could go in 1 hour, and then you multiplied it by how many hours you've been traveling, and that's going to tell you your total distance. So now that we did it with the numbers, do it with the more difficult numbers at hand. You're going to take how far you can go in 1 hour, which was 11 1/3 miles, and you're going to multiply that with how many hours you were traveling. And in this case, it was 3 3/4. Okay, and that's one of the biggest test taking strategies or word problem help you can do for yourself, is try to make the numbers a lot easier to deal with, and make them numbers they don't even necessarily have to round to those. Just make them numbers that you could easily work with if you were to add, subtract, multiply, or divide them, and then logic through what makes sense. Once you figure out an answer that makes sense, then think to yourself, okay, what operation did I do to get this answer? Oh, I multiplied these 2 numbers. Then do that same operation to the 2 more difficult numbers that happened in your word problem. All right, I think we're ready to move on. Let's go ahead and take a look at the backside. Okay, on the backside, it says that Cheyenne drove 3 3/4 miles yesterday. Today, she drove 4/5 of that distance. How far did he travel today? Well, what do you think? One of my hints to you is when you see a fraction followed by the word of some other number, that means you're going to multiply. And you're like, but I don't see another number there, Miss Love. It just says that distance. Well, that distance is talking about the distance he drove. of 3 3/4 mile. Well, 4/5 times the distance of 3 3/4 miles. So 4/5 times that distance. Now, it's not just whenever you see the word of, because of is kind of like the word the. It comes up all the time. But when you see a fraction followed by the word of some other number, then you're multiplying those numbers. Okay? And again, this is technically talking about another number right here because it's saying 4/5 of that distance of 3 3/4 miles. Okay, for the next one, it says Miles practices playing the piano for 2 4/5 hours every week. His friend Nick practices 2.5 times more than Miles. How many hours does Nick practice? Okay, well, who practices more? Nick does. By how much more? 2.5 times more. So I'm going to take however much Miles does, and I'm going to multiply it by 2.5 in order to find how long Nick practices for. Okay, again, I want you guys to be trying these on your own first, and then pause the video, try it, and then unpause it and come back to see how you did. Okay, for our next one, it says there was 9/10 of a cake in the fridge, and Octavio ate 1/3 of it. How much cake did he eat? Well, 1/3 of it. 1/3 of what? The 9/10 of the cake that was left. So 1/3 times the 9/10 of the cake that was left. The next one says there was 5 5/8 pieces left after the Priscilla's birthday party. She decided to invite the neighborhood kids to come and have the rest of it. They only took 4/5 of what was left over. So how much pizza did they take? What do you think? Well, this is another one of those fraction followed by the word of some other number is when we multiply them. So 4/5 times, and you're like, there was no other number. Well, technically there is. 4/5 of what was left over. Well, how much was left over? The 5 5/8 was left over. Okay, the next one says 9/10 of Miss Sarah's class said they liked Jolly Rancher candies. Of these students, 2/9 said that their favorite flavor was grape. So what fraction of her students like grape Jolly Ranchers? Okay, so 2/9 of those students that said they like Jolly Ranchers like the grape flavor. So 2/9 of the 9/10 who said they like Jolly Ranchers prefer grape. The next one says Quasim is 6 1/6 feet tall, and his sister Raya is only half of his height. How tall is Raya? What do you think? Okay, well, how tall is Raya? And it says Raya is half of his height, and half of his height is the 6 1/6. So fraction followed by the word of some other number, and that other number is his height, which is 6 1/6, means we're going to multiply. Okay, the next one said Taylor had 9.5 pies left and wanted to split the leftovers evenly for her friends. If the pies needed to be evenly shared between 4 people, how much would each person get? Well, whenever you want to split up something evenly, that usually means that you're going to divide. So you take how much you started with and then divide it into how many pieces or how many people you're going to divide it up amongst. So you're dividing it up amongst 4 people. And what are you dividing up? The 9.5 pies you had. Now, we haven't done any division ones yet, but the same rules apply at the beginning as when you're multiplying. We want to change these to improper fractions. So that's 18 plus 1 is 19, divided by, to make the whole number a fraction, you just put it over 1. Now, am I good to go? Can I cross cancel these? No. You cannot cross cancel until it's set up as a multiplication problem. And we technically don't know how to divide fractions. We only know how to multiply them. So I do keep, change, flip, meaning you keep the first fraction the same. Change division to multiplication and flip that second fraction so that then you're technically multiplying by the reciprocal. Once you have that, then you look to see if anything can cross cancel. It can't. So you multiply across and then change it back to a mixed number if needed. So 19 divided by 8, 8 goes into 19 twice. And when you subtract that, you get 3. So you put your remainder over what you divided by. So each friend is going to get 2 3/8 pieces of pie. Okay, our next one says Uriah had a 22-inch ribbon and wanted to cut it into smaller strips that were 2 3/4 inches long. How many strips of ribbon would there be? What do you think? Well, the trap is to think, oh, you're cutting it, so I'm just going to cut it off. So I'm going to subtract it. But think about what's happening. You're cutting it into equal strips that are each 2 3/4 inches long. So this is one of those splitting up evenly problems. You're taking your total amount you have and you're dividing it into equal sized pieces that are all 2 3/4 inches. So I'm going to divide it. Okay, second to last one says a construction crew had to repair 12 miles of road. They are able to repair 1 2/5 miles of road each week. How many weeks will it take for them to repair the road? Okay, let's try to make these easier numbers. What if it said, okay, you have to repair 12 miles of road. That's a fine number. Okay, so have to repair 12 miles. Okay, and let's make that an easier number. Let's make it 2. Even though it doesn't round up to 2, 2 is an easier number that can multiply or divide or add or subtract with 12. So, okay, they can do 2 miles per week. Okay, so how many weeks is it going to take them to have those 12 miles done? Well, a lot of your brains are already saying, oh, 6. Well, how did you get that? Because after 6 weeks, those 12 miles will be taken care of. You did 12 divided by 2, right? Well, in reality, it wasn't divided by 2. We're actually dividing by this number. But you see how your brain is smarter than you give it credit for. If you just make it easier numbers, your brain knows what to do. And so then take a step back and be like, okay, brain, help me out. What operation did you do to get the 6? And then it'll tell you, oh, well, I did 12 divided by 2. That's how I got the 6. Okay, thanks. So I'm going to do 12 divided by 1 2/5 then for this complicated looking problem. Okay, last one. It says Victor drove 60 miles in 2 1/4 miles. What was his average speed per hour? What do you think? Well, let's make it an easy number. Okay, if you can go 60 miles in 2 hours and you want to know the average speed in 1 hour, well, think to yourself, how did you get from 2 to 1? Well, you divided by 2. So then divide this by 2 and you get 30 miles. So what you're doing is, if you want to know how much it was per hour or the average, okay, you basically are just dividing the top by the bottom number, whatever that may be. Okay, because you want to get the bottom to become 1, and that'll tell you the average per 1 of something. So whatever they say, they want it per hour or per, I don't know, you're talking about how much it costs per orange or per watermelon. Okay, whatever comes after the per, that's what you want in the denominator. So this was 60 miles in 2 1/4 hours. Well, you want to know how far can you go in 1 hour then? Well, how do you go from 2 1/4 to 1? You would divide it by 2 1/4. And whatever you do to the bottom, you got to do to the top. Okay? So then do 60 divided by 2 1/4, and that's going to give you your answer. Okay? And then again, my trick to you is whenever you see the word average or something like that, or they see it say find the unit speed, that's rare. Normally they're going to say average. You're going to divide, and then how you know what number to divide by what is whatever they say per this, that's per 1 hour. So you want that unit to become 1. So that's what you're going to divide both the top and bottom by. And that's your bottom unit. And there you go. Hopefully this helps you get a little bit more comfortable with how to set up word problems. keep reviewing that sheet at the end of a lot of your packets that have a lot of those indicator words of when you add, subtract, multiply, or divide. Treat them like flashcards. Okay. Ask a sibling or an older parent. Say, hey, if I were to show you the one that says, how much more than, or just ask them, like, can you read me these words? And I have to tell you if it means add, subtract, multiply, or divide. And tell them that you want them to go out of order, and mix it up and like repeat some of the ones that you missed the first time around so you get more practice with them. If you review a lot of those indicator words a little bit each night, you're going to get that much more comfortable with word problems. And sadly, those aren't all the words that possibly come up. There's an infinite number of possibilities. I can't give you all the cheat words. Those are just a lot of the popular ones. So the other big hint is, again, dumb the numbers down to easier numbers to deal with. And then your brain will usually figure out the answer, okay, or logic through, try different possibilities, see what answer makes sense. Once you find the answer that makes sense, think about what operation you did to get those. Oh, hey, I divided those. So once you figure out the operation you did, then do that same operation with the numbers from your original word problem. All right, and that's my advice to you on how to get better at setting up word problems. Now, if you want to actually solve these problems, go ahead and solve them and then check yourself on the answer key. You got this. You're going to do great.